is a submarine radar set which was developed towards the end of the war. I think the start of this one actually started off about 1943. It's actually derived from two different sets. The first set is this chap here, which is a pulsar. This takes in 500 cycle AC electricity, changes it into the various voltages needed for the valves, and also produces by this tube up there a trigger pulse which fires this thing, which is a hydrogen Tireless. When that fires, it drains off power from the pulse networks, and the pulse network then produces a pulse of about 5,000 volts, which then goes up into either one of two circuits. So this is usually called, nowadays it's called a modulator. In the old days it was called a pulsar, but this was the unit. Now later on, this set was started around about 1941. Later on this was modified, and the set, this is not actually in a sense a cobbled up version of the old set. It's in fact using the old set's framework, part of the equipment, to generate two sets of pulses. One set that goes up into valves which you'll see here, which works a radar running at 214 megacycles. That's about 1¼ meters. The other, by switching here, there's a big switch arrangement which isn't on the original version of this, which then can switch the pulse up through a high tension lead into this. Now this is a separate unit entirely. This works on 3 centimeters, that's 10,000 megacycles. It gives a very sharp image on your radar screen when you're looking at it, and also is useful for searching, mainly for surface vessels, particularly submarines and submarine periscopes. This was, at its day, this was cutting edge technology. I'll explain this later because it's a separate issue. Now both sets came together through here in this version, and in the other version via a spark gap, which unfortunately is missing. All it was a 1/100th of an inch spark gap, which on a tuned length of parallel wire shorted out the aerial from the receiver, which I'll show you later, so that when the pulse fired on the 214 meg set, the receiver was blocked out, wasn't burnt out by the power, because there's a lot of power here, and the signal went out onto the aerial. The spark then released, no spark, open gap, and then the circuit to the receiver became open, and it could then receive the returning signal reflected off what the pulse of radar had produced. Right, this is the receiver which works for both the long wave and the short wave. It has a small oscillator in here which gives you the 214 megacycle through an intermediate frequency amplifier. Now the circuit from here, which is the 3 centimeters, generated by a magnetron, this is a magnetron, via the pulse transformer, which takes the voltage that's produced by here. This then sends out a pulse. This is the switch, the spark gap equivalent, to stop the receiver being burnt out by the pulse from that. This is the receiver section. This goes into a head amplifier, which then comes down, goes into here, and is put into this row and amplified and out as the resulting pulse. The 3 centimeter power doesn't go out by cables, it goes out with a waveguide. This is the waveguide which takes the power from this magnetron, here's its magnet, and produces it. It also has a rather interesting system here by sensing whether the signal drifts high frequency or low frequency, and it adjusts the reflector of this klystron, which is the local oscillator for the centimetric radar. That's a very brief outline. you'd have to go into it in detail to understand the full significance of it. It has worked. I've worked both the 214 meg and got signals from ships. I've used this and I've got signals which I know came from at least 10 miles from the ships, which is the spec of the set. This unit is an Admiralty design. It's a British design. In the internet it's always said that it's a Canadian design, 3 cm. It isn't. It's 3 cm and it's an Admiralty pattern unit.
And so what was this fitted? What year was this? And what was
this was about 1943-44.
And fitted to British submarines.
British submarine. These came either from the Scorcher or the Tireless. I think they were S class or T class. They both had the same set of radar.
Mm-hmm. And when did you get it?
I got it in 1959 at Matty Pearson's in Glasgow, and it was being scrapped from the submarines that were in the dockyard. I think it was Faslane actually.
Mm. So it was still running in boats in the 50s?
It was running when it was taken out. This I think has been partly cannibalised to take this switch, because the part of the switch is missing. It switches from the metric side, 214 meg, to the centimetric side by turning it around. I've managed to fix it up with wiring so that you can change it, but you have to do it manually, altering the connections. Both work. Goes beautifully. It runs quite remarkably quietly. There's no. The only thing you can tell that it's running is a little beautiful blue glow around the side of the hydrogen thyrotron. Originally it had a mercury vapour thyrotron with the heater to keep vaporize the mercury, but it's changed over to hydrogen, which is better.
And was this the one that you said had a special valve?
The special valves of this is CV214 Magnetron.
Right.
The disc seal valve in here is unusual. Oh, and the output from the metric came into these two valves here, which are called micropups, and they produced the output from that was a pulse of 100 kilowatts. The output from this was a pulse of 40 kilowatts. These were tuned by these two parallel tubes called Lecture wire tuning. Worked completely smoothly, no problem at all.